Hi, welcome back to 5.6. This is our third video for example 3. In this example, we're going to look at a predator-prey population. So when two animals have predator-prey relationship, the population of each over time can be modeled with a sinusoidal function. If the population of the prey is large, the population of the predator increases since there is an adequate food supply. As the population of predator increases, the population of prey decreases. Eventually, there is not enough food for the predators, and they also begin to die off. As the numbers of predators declines, more prey survives, and the population of prey increases again. So there's this kind of relationship where the one kind of follows along the other. Suppose the number n of prey in a given area could be modeled by this function here. So this is for the number of prey, where t is the number of years since a base year of 1990. So year 1990 would be time 0. Okay, what was the population of prey in 1990? So let's go ahead, we'll start answering this. So in 1990, t equals 0. So what this means is n of 0 we can plug in t equals 0 for time. Sine of 0, because this actually is 0 there. Sine of 0, so think of the unit circle at 0 degrees, the y value is 0. So this whole first part is going to go away because that's all going to be 0. So we have 0 plus 500. So we can say that the population of prey is 500. Okay, another way to look at this is also a sine function up here. Okay, and the center line is at 500. Okay, note there's no phase shift, and sine always begins at the center line. Okay, so if there's no phase shift, it's going to begin here, which makes sense. That's exactly what we got. Okay, part B, when did the population reach a maximum? So there's a couple ways you could do this. You could find the period. Okay, the period is going to be 360 over k, and the k value in this question is 90, right? That's our value for k. So 360 over 90 is just 4. So it takes 4 years to do one full cycle. So if we think about this sine graph, it's beginning at 500. So remember how our points start at the center line, they go to a maximum, back to the center line, then minimum, then back to the center line to get this nice curve. So this maximum occurs at a quarter way through the cycle. That's at 1/4 of a cycle, or 1/4 of a period. So if the period is 4 years, a quarter of that will allow us to be at a maximum. Okay. So maximum occurs at 1/4 of a cycle. So therefore at 1 year, the prey reach a maximum. Okay, we could also do this algebraically. We could write out the equation. N of t equals 250 sine of 90t plus 500. So a maximum value would be center line plus amplitude, 750. So we can sub 750 in. Okay, this is max plus center line. And now we're going to go ahead and solve for t. So we're going to subtract both 500 from both sides. That cancels that out. So then we're going to have 250 equals 250 times sine of 90t. We'll divide out the 250 from both sides. That gives us just 1. Okay, and you might have said, okay, Mr. A, that could have been pretty obvious. So in order to get a maximum, this sine of 90t, remember this always ranges from -1 to 1. To get a maximum, this needs to equal 1, which is what we got here. So you can actually kind of skip some of this stuff and you can go right to that. Now solving for t. So when does sine equal 1? Well, the angle needs to be 90. Okay, so if this up here, sine of 90t equals 1, and sine of 90 equals 1, that means these need to be the same, right? If they both equal 1, the angles have to be the same. So we can write 90t equals 90, therefore t equals 1. Okay, notice that's exactly what we got over here when we took a quarter of one full cycle, a quarter of a 4. Okay, part C. What was the maximum population at this time? Well, we already found that out. Maximum is 750. 750 prey. Part D. When did the population reach a minimum? So if you remember how this sine graph starts, center line max, center line minimum. Okay, that's one full cycle. It's 3/4 of the way through. 3/4 of a period. So 3/4 of 4 is just 3. So it's going to take 3 years. Okay, 3 times 3/4. Sorry, 4 times 3/4 equals 3. Okay, so it take 3 years. Okay, this also could be done algebraically too, like how we did with the equation up here. We could find our minimum and plug that in. So I'm actually going to show that before we start. So we could plug in, let's just write everything out first. So 250 sine 90t plus 500. Okay. So our minimum is the center line minus the amplitude, which is 250. Center line minus amplitude. Okay, so we're going to subtract 500 from both sides. That cancels this out. So we get minus 250. Divide both sides by 250. We get -1 there. Those cancel out. So we have -1 equals sine of 90t. Okay. So at what angle does sine equal -1? Well, we know that angle needs to be 270. Okay, so therefore 90t must equal 270. Divide both sides by 90, and we get 3. Okay. Notice that matches exactly what we had found over here. Right? So 3/4 of the period 4 was 3 years. Okay. All right, part E, almost done here. What was the minimum population of that time? Well, we found that over here. It was actually 250, right? The center line minus the amplitude. Okay, so the prey has a minimum of 250 and it has a maximum of 750. That was the max value. Yeah, right there. Okay, lastly, part F. How many years have passed between making maximum populations? So it has to be the period. So 4 years. So maxes occur every 4 years. Okay, all right, that is it for this lesson. Hope you guys found this helpful. I'll see you later.